Hi, everybody, and welcome back to our lecture. What we're going to be doing today is we're going to be looking at the Krebs cycle, also known as our citric acid cycle. So what we're going to try to do is we're going to identify exactly where does this happen, what are the steps for this, and then again, what are we trying to produce, what are we trying to make from this cycle. So just looking at this background over here, we went ahead and covered our glycolysis. We've identified that we're taking our glucose, which was our 1, 2, 3, 4, 5, 6 carbon chain, and we're lysing or breaking that apart in order to produce two pyruvates, 1, 2, 3. And remember, we're producing two ATP from that, as well as two NADH. So that was everything for glycolysis in that first step. What we're going to be doing is we're going to be focusing now on our second step, which is our citric acid cycle, and this is going to be the first step in our mitochondria. Now, one thing I want to make sure you guys understand is the citric acid cycle is going to be a very complex series of biochemical reactions that are going to happen in order to produce things that we need in order to get to our electron transport chain. Now, although this slide is going to be pretty short, it's only going to be two, we're essentially doing an overview of what the Krebs cycle is, but there is a lot more in-depth information for the Krebs cycle. So again, I want to make sure that you guys are aware that we're just kind of doing a quick overview to see exactly what's going on in that Krebs cycle. We're not going to do a very, very deep dive. We're looking at the major components needed in order to move on to the electron transport chain. So with that being said, let's go ahead and check out the Krebs cycle. In this case, the second step in cellular respiration. So the Krebs cycle is also, again, known as the citric acid cycle. And again, it's just going to be a series of biochemical reactions. And the main idea for this is to try to break down our pyruvates, which again, remember are three carbons, 1, 2, 3, two carbon dioxide, in this case, our one carbon, because we have our single carbon right here, and then we have our two oxygens over there. Now, the Krebs cycle is going to take place in the mitochondria. So unlike glycolysis, which was happening right here in the cytoplasm, we are now moved into the mitochondria. So again, this is going to typically be known as our powerhouse of the cell. And the reason why this is so important is because this is where we're going to start to produce a lot of the precursors in order to move to the electron transport chain, in order to produce a large amount of ATP. And again, that ATP is going to be our energy dense molecule that's going to help facilitate movement. So let's go ahead and take a look at the Krebs cycle. We're going to go ahead and break it down into two steps. Again, like I said previously, the Krebs cycle has many, many different components into it. Again, it's a cycle, meaning that it's going to continuously be revolving around in order to produce many of these components. Again, it's going to be very, very complex, but again, for our purpose and our scope, we're only going to kind of look at the major things that we need in order to move on to our second step. So the first step, again, we're taking our two pyruvates that we produce from glycolysis. Remember, those are C3, three carbon molecules, and they're going to enter the Krebs cycle, remember, which is going to be in the mitochondria. So we've moved from the cytoplasm into the mitochondria. And again, we're going to be breaking them down into four CO2s. In this case, they're going to be one carbon molecule. Now, CO2 is going to be a waste product that must be eliminated by the body by breathing it out. Now, in step two, what we're going to do is we're going to take or make two ATP, six NADHs, and two FADH2 molecules. Now, these are produced, and NADH and FADH are electron carriers and will be used in the final step for cellular respiration. Okay, so again, in step one, we're taking two pyruvates, three Cs, and they're entering the Krebs cycle. Again, they're coming from the cytoplasm and they're coming from glycolysis over to the mitochondria and entering the Krebs cycle. Again, the cycle is going to be a continuous biochemical reaction that's going to be producing our two ATP, our six NADHs, and our two FADH2 molecules. And again, the reason why that's important is one, ATP is energy, and two, these two pieces, again, are going to be used in our final step of cellular respiration, which is going to be our electron transport chain, which is going to help us produce a large quantity of ATP. So this is essentially what the summary is going to look like. We have our inputs, which are going to be our two pyruvates located right here. And our outputs, what we're trying to produce is our two ATP here. We have our six NADHs here, and we have our two FADHs over here. Now, some byproducts from this production is going to be CO2. So in this case, we have four of them. And remember, this is going to be waste. So we're going to exhale this out in order to remove or get rid of that CO2. Because again, we don't really need that. We are also going to be producing heat, which is something that's going to help us because again, it's going to help us maintain our body heat. So again, we're taking our two pyruvates and we're producing this 1, 2 ATP, 2, 6 NADH, and I'm sorry, 6 NADH, and then 2 FADHs. And all of these are going to be moved over to the electron transport chain. All right, and just like that, that is going to be our summary of the Krebs cycle. So again, if you do have any questions, comments, and concerns, please feel free to reach out. And I look forward to seeing everybody in the next lecture.